This topic is called Solving a System by Graphing, and the learning goals are pretty straightforward. Find the solution to a system of linear equations by graphing the two equations. Find our solution by graphing. And we know what the solution to a system of linear equations is. It's going to be the point of intersection of the two lines. And we talked about this in the last lesson, that the solution to a system of linear equations is the point x and y that satisfies both of these equations, or the point where the two lines meet when we graph them. So pretty obvious. To solve the system, a linear system, we graph both equations, and then we find the point of intersection. So if we wanted to find the solution to the following system, y equals x minus 8 and y equals 1/2 x plus 1, we could basically, we want to graph these lines. And we can graph these lines in any old way that we wanted to. So if we're looking at the first one here, maybe we make a table of values here, okay? X and y. And we choose some values for x, like negative, not negative 0, x, y. Let's choose negative 2, 0, and positive 2. And then we can take each of these x values, sub them into our equation. For instance, y equals negative 2 minus 8. We get y equals negative 10. And that's going to give us the point negative 2, negative 10 here. So let's plot this in blue down here. And we're going to do this for a couple more points here. I would recommend doing at least 3. So for x equals 0, our y value is going to be 0 minus 8. Y is negative 8. So we've got the point 0, negative 8 here, which is right here. That's our y-intercept. I guess we could have gotten that just by looking at the equation. And we'll do one more point here. When x is equal to 2, y is going to be 2 minus 8. That's going to be negative 6. So our point is 2, negative 6 right here. And then we just want to draw a straight line through these points. So I'm going to just draw my line like this. And we want to extend this line so it goes all the way across from one edge of our graph to the other, okay? Because we're not sure where that point of intersection is going to be. We just want to make sure we give ourselves plenty of room. So we could graph the second one using a table of values, or we could do it using the slope and the y-intercept. We know that our slope is negative 1 over 2. So our rise is negative 1, our run is 2, and our y-intercept is that point positive 1. So we could start from our y-intercept of 1 here, and we could go down 1 and over 2 to get to the next point, down 1 and over 2, down 1 and over 2, and so on and so on. And then draw a nice straight line through these points here and make sure we extend it so it goes all the way to the edges of our graph. But we can already see where that point of intersection is. The point of intersection is going to be there at 6, negative 2. So our solution is 6, negative 2, or x equals 6, y equals negative 2. So as long as you can graph the lines, you can find the point of intersection. Here's a second example here. Again, the instructions are the same. Graph both equations on the same axes. The solution is the point or the point of intersection. Here we're given two equations in standard form. So what we might want to do is find the x and the y-intercept here. So to find our y-intercept, I'm going to set x equal to 0 in this equation. If x is 0, it's like this 2x is just gone. So it's going to be y equals 5. That gives us the point 0, 5, which is going to be right there. To find our x-intercept, we're going to set y equal to 0. If y is equal to 0, we get 2x equals 5, or x equals 5 over 2, or 2.5. So our point here is going to be 2.5, 0. So we've got to be really careful with this 2.5. It's going to be right there. So we'll take our line here, and we will just join these 2 points together, and then extend this so it goes to the edges of the graph like that. Okay. And there's our first line. And we can do something similar for our second line. Set x equals to 0 to find our y-intercept. We get negative 2y equals 10. Y is equal to negative 5. So we've got a point right here. Y equals negative 5. And we are going to set, to get our x-intercept, we're going to set y equal to 0. We get x equals, just x equals 10. So y equals 0, x equals 10. We get a point way out here. All right, let's take our red line here, and we're going to connect these two lines together, and then we're going to extend this back like this, and we're going to look for the point of intersection. And we can see here that our point of intersection looks pretty close to being the point for negative 3. So I haven't drawn my lines exactly, but I'm just going to choose to do this in terms of the closest sort of integer point. So our point of intersection is the point for negative 3.